A pressure exerted by a gas in a mixture is known as partial pressure. If a container is filled with different gases, then the pressure exerted by any one gas is its partial pressure. So each gas contributes and makes total pressure. Partial pressure is applicable only for gases. Let's assume that atmospheric pressure is 1 atmosphere. And the air has a lot of gases. We say nitrogen in the air has 0.78 atmospheric pressure. Oxygen has 0.21 atmospheric pressure. So total pressure is the sum of all partial pressure. Dalton's law of partial pressure. It states that the sum of the partial pressure of all the gases in a mixture is equal to its total pressure. Each gas has specific partial pressure. It is the pressure gas will exert if it is there in the container. Here, we assume that between gases there is zero attractive force. We can express partial pressure in mole fraction form too. Mole fraction is abbreviated by the x. The mole fraction of a gas is the amount of mole in the gas mixture divided by the total number of moles of a mixture of all gases. Dalton's law of partial pressure is used to calculate the partial pressure of the gas, moles of individual gas, and total pressure when we know other things in the equation. Derivation from ideal gas equation. If we have a mixture of 4 gases in a container having volume 5, pressure of 4 gases is P1, P2, P3, P4. Several moles of gases are N1, N2, N3, and N4. Here the temperature is constant, so by applying the ideal gas equation we get. The ideal gas equation is as follows. A mixture of gases has several moles of different gases. By applying the ideal gas equation for each gas we get. Now we can multiply equation 1 with RT divided by T. Hence we can calculate the partial pressure by product of the mole fraction and total pressure. Let's take an example. We have a mixture of gas in a container of 15 liters. We know the moles of each gas of oxygen and nitrogen and calculate the partial pressure of a gas by the ideal gas equation. We can also calculate the number of moles of any gas by the ideal gas equation. We know the pressure, volume, and temperature of gases.